We will cover strictly questions about Unit 1, limits and continuity for AP Calculus, AB and BC. Now, there are some questions that I'm not covering here that also involve limits and continuity, but they also involve further topics like derivatives and integrals and fundamental theorem of calculus and stuff like that. So I'm not going to be covering that in this video. This video is going to focus strictly on questions dealing with limits and continuity. But in future videos, expect to see questions from limits and continuity because AP Calc is like a house. It builds on each other. You need to have your base before you can move along to building the bedrooms, the kitchen, the attic, the roof, whatever. Enough with bad metaphors. Let's get to calc. The graph of the function f is shown above. Which of the following statements is false? The limit of x to 2 of f of x exists. The limit is x to 3 of f of x exists. The limit is x to 4 of f of x exists. The limit of x to 5 of f of x exists. Or the function f is continuous at x equals 3. So for a limit to exist, right? Let's use this x equals 2 example. Or I'll make it general. If the limit as x to a of f of x exists, if it exists, that means that the limit as x to a from the left, denoted by a minus, equals the limit as x to a plus from the right, denoted by the positive sign here. This basically saying the limit from the negative direction is equal to the limit from the positive direction. So let's see if this holds the case for x equals 2. As we approach 2 from the negative direction, so this way, 2 is x to 2, f is approaching 2. So I'm going to make a little minus and a little plus here. For 2, the negative limit is 2. And the positive limit from this side is also 2. So the limit is x to 2 of f of x. It exists. The statement is true. It's 2. So it is not false. We can get rid of it. As x to 3, well, let's see. What's the limit as x to 3 from the negative direction? Let's go up like this. We see it's approaching 5, which means that if the limit from the right also equals 5, the limit does exist. The limit from the right up here, still 5. Limit exists, statement is true. The limit is x to 4, well, from the bottom, from the negative direction, it equals a little bit below 2. I'll call it like 1.8. But from the right, or the positive direction, it's 4, meaning this limit does not exist, which means the statement is false, which means the correct answer is C. Now, important thing to note, this is the key concept you should be taking away from this, right over here. If the limit of x to a of f of x exists, the limit as x to a from the negative direction must equal the limit of x to a from the positive direction. That is the key concept that you must understand from this, is that will be tested on a lot, whether it's just your regular limits and continuity test, or even questions like these on the AP Calc exam. Let f be the function defined above, for which value of k is f continuous at x equals 2. So for a function to be continuous, this condition must be met. The limit as x to a of f of x has to equal f of a. If a function is continuous, this holds true. So For which value of k is f continuous at x equals 2? Well, we need to find the limit of f of x as x goes to 2, which we can use this for. So the limit as x approaches 2 of 2x plus 1 times x minus 2 divided by x minus 2. So now, first thing we can do is we can directly substitute 2 in. And this will get 5. Sorry. This right here will get 5. This will get 0. And this will get 0. So 5, not here. So I'll do this little work off to the side. 5 times 0 over 0 is indeterminate. So we need to see if we can do anything else. Anytime you have 0 over 0 in any way, it is indeterminate form. Okay? So now we go here. We see what can we do to this? Well, x minus 2, same on the top and bottom. We can get rid of it. We're left with 2x plus 1. Now we can see what the limit is x to 2 of this, which is 5. 2 times 2 is 4, plus 1 is 5. So in order for f to be continuous, this value must be 5. Because otherwise the limit as x to 2 of f of x does not equal f of 2. Again, I'm not doing a full lesson on limits here. This is just going over some questions. I'm still trying to provide the general topics. If you have any questions for me, please let me know. And this answer got spoiled. I don't know why. But let's see if we can. Let's show why it is. The line y equals 5 is a horizontal asymptote to the graph of which of the following functions? Now, a horizontal asymptote means that as x approaches infinity or negative infinity, so first for a line y equals, we'll say a, to be a horizontal asymptote, the limit of x to infinity of f of x has to equal a, or the limit is x to negative infinity has to equal a. So let's see, in this case, as we approach infinity, what happens to each of these functions. Sine of 5x over x. So as x goes to infinity, this will go to infinity, and this, well, sine will always be between 0 and 1. So between negative 1 and 1. So we're just going to be not going past 1 or negative 1, and this is just going to keep growing. So this is going to approach 0. The denominator is going quicker than the numerator, therefore it's going to go to 0. Y equals 5x, well, this is just going to approach infinity as x goes to infinity. Y equals 5x, the graph just looks like this. It's a straight line up. It will continuously go up. Y equals 1 over x minus 5. Now, as x goes to infinity, this means we have 1 over infinity. And if we ever see this, that is 0. The denominator is increasing more than the numerator. It is not C. Now, D, y equals 5x over 1 minus x. Now, in this case, these functions are going to be expanding with the same degree. Like, there's a first degree term here and a first degree term here. So the way to determine the limit as x goes to infinity is to take the coefficients of these two highest degree terms, in this case 5 and negative 1, and divide them, which means we get negative 5, which means y equals negative 5 as x goes to infinity is an asymptote, which in this case is not, which in this case would not be correct. So now let's try E. Notice that I've only done the limits as x to infinity for these. Now, very well, one of these could have a limit of x to negative infinity that goes to 5. But first, I'm checking all of them as we go to infinity, because if just one of them does, that means that it has a horizontal asymptote and we don't need to check this. So let's try here. Again, we have the same highest degree term like we did over here. X squared and x squared is going to grow at the same degree rate. So the limit is going to be the ratio of the coefficients, 20 over 4, which is 5. Which means our correct answer, as shown here, is E. Just a quick refresher for these type of limits. If you're taking a limit to infinity or negative infinity, I'll just do one example. If we have something like 1 over x to infinity or negative infinity, the denominator is going to be growing greater than the numerator. Therefore, this will go to 0. This is the same thing for something like x squared over x cubed plus 5. X cubed will go greater than x cubed. So as we go to infinity or negative infinity, this will go to 0 because the denominator is going to be growing quicker than the numerator. If it's the reverse and you have like x cubed plus 5 over x squared, the numerator is going to be growing quicker than the denominator. So it will either be going to infinity or negative infinity, depending on signs and stuff like that. However, if the coefficients are the same, its growth rate is determined by the coefficients. So for this one up here, x squared will grow at the same rate, but 20x squared will go quicker than 4x squared. So the difference will be that division. 20 over 4, which equals 5. And that is your limit to infinity. So now let's look at a part 2 question. Let g be the function defined by g of x equals f of x for negative 5 is less than or equal to x, which is less than or equal to negative 3. And f of x, as shown over here, is square root of 25 minus x squared for negative 5 to 5 inclusive. And from negative 3 to 5, g of x is x plus 7. And they're saying, is g continuous at x equals negative 3? So, if we remember from earlier, for g to be continuous, that means the limit as x to negative 3 not only has to exist, it has to equal g of 3. So let's do the easier part of the two, finding what g of 3 is. All right, so let's look at g of 3. G of 3, which part does not negative 3, or g of negative 3, my bad. Where is negative 3 on this? Okay, it's right here. It's included in f of x. So let's evaluate f of negative 3. F of negative 3 will be square root of 25 minus negative 3 squared, which is 9. So the square root of 25 minus 9, which is the square root of 16, which is 4. So g of negative 3, so g of negative 3 is equal to 4. Now, what's the limit as x to 3 of x to negative 3 of g of x? Now, we know from the left side it's going to equal 4 because this function is continuous. Or not because it's continuous. Because this function from negative 5 to negative 3 inclusive, it would only have a whole, or no, yeah, it is because it's continuous. And you can show this function, and you should know that this function is continuous because it will only not be continuous past from at least from -5 to -3, it will always, you can test this out yourself. There'll always be a value. You can graph this yourself and see that it is in fact continuous. So moving on, that was a bad explanation why it's continuous. Let me re-explain. The square root of 25 minus x is continuous as x goes to -3 because you could directly plug it in at this point. The limit as g of x goes to -3, x squared we know is a continuous function. We know it looks like this. It is continuous, no holes. So unless there's a domain issue, the square root of 25 minus x squared will be continuous because every part of it is continuous. The only time there's a domain issue is when you go outside, which is when you go to the left of -5 or to the right of 5, because that makes x squared greater than 25, making this the square root of a negative number. So what this means is that since we don't go outside of there, there's no issues, it is continuous. So we know the limit from the left, the limit of x to -3 minus of g of x is 4. Now we have to see what the limit is from the right, which would be used by plugging in -3 to this. -3 plus 7 is 4. So since the limit from the left equals the limit from the right, that means that this limit exists. Since this limit exists, that means that as x goes to -3 of g of x, this limit has to be 4 because it's the same on both the left and right sides, which means this function is continuous at x equals -3. Notice how the question says, use the definition of continuity to explain your answer. This is the definition of continuity. If you want it to be safe, you could write in an additional statement saying a function is continuous when the limit not only exists at a point, but is equal to the function's value at that same point. So, as long as you have this work to show the limits from both sides, and then you show the function's value at that point, you will get a full 2-point response. I have some notes about the response here. So, the definition of continuity, as I said, it's when a function's limit exists and is equal to the function's value. It was worth 2 points. 1 point was given for considering one-sided limits, and the other point was given for a correct answer with an explanation. That is it. So thank you guys for watching. I hope you enjoy. If you have any questions, please let me know in the comments. And goodbye.